Scientists were just beginning to discover the anatomy of the atom. Now they wanted to understand its behavior, specifically the mechanism that enabled the atoms of certain elements to combine with the atoms of other elements to form new substances. In the early 1900s, American chemist Gilbert Lewis developed a model of the atom that provided an answer.
It is he who explained that electrons in atoms, and chemistry is about electrons, it's not about nuclei, that the electrons in atoms went in shells around the nucleus.
In Lewis's model of the atom, each shell allows only a maximum number of electrons. Lewis theorized that two chemical elements might combine to form a compound when they give up or accept electrons from their outer shells. For example, on their own, sodium and chlorine are hazardous. But when a single sodium atom gives up the electron from its outer shell, and a single chlorine atom's outer shell accepts it, this exchange allows the two to bond and form the compound sodium chloride, table salt. Gilbert Lewis's theory was an extraordinary breakthrough. It enabled scientists to begin making chemical compounds, millions of them, compounds that have shaped the face of modern life. Our next great discovery started in the 1890s with the discovery of an unknown radiation called X-rays. It caused a sensation, and scientists immediately began looking for other substances that emitted strange, perhaps valuable forms of radiation. Over the next several decades, a number of scientists investigated the phenomena and together ended up shedding light on one of the great scientific sleuthing episodes of modern science. French physicist Henri Becquerel made the first significant breakthrough. In 1896, he conducted a series of experiments to see if various minerals emitted radiation. One of the minerals he happened to test was uranium. Becquerel's technique was to place different objects on top of an unexposed photographic plate, still wrapped in protective black paper. He would sprinkle the uranium onto another piece of black paper, then enclose the object between the uranium and the photographic plate. Later, Becquerel would develop the plate, and without fail, a ghostly photographic outline of the object would appear. From these experiments, Becquerel was able to prove conclusively that he had found a source for the mysterious radioactive rays that everyone was looking for. That source was uranium. From Becquerel, the investigation of radioactivity was taken up by Marie Curie. Curie and her husband Pierre undertook the job of isolating whatever elements were responsible for the radioactivity in uranium ore. For 2 years, the Curies boiled, sifted, filtered, and processed several tons of uranium ore. Finally, they succeeded in isolating 2 new elements contained in the ore, which they called polonium and radium. Marie Curie concluded that radium was 1,000,000 times more radioactive than uranium. More importantly, she determined that the mysterious form of energy which enabled radioactivity to penetrate other materials was not the result of a chemical process, but seemed to be atomic in nature. Unfortunately, her discoveries came at great cost. The dangers of being exposed to radioactivity were still unknown at the time, and in 1934, Marie Curie died of leukemia, believed to have been caused by radiation poisoning. Even the notebooks that she used to record her observations are still considered too radioactive to handle. It was the atomic nature of radioactivity that eventually attracted the interest of physicist Ernest Rutherford, whom we already met in the discovery of the electron. Rutherford found that radioactive material goes through a natural process of decay. As it moves through the process, the radioactivity spontaneously emits unstable and highly charged energy particles with the power to penetrate matter. Rutherford called them alpha and beta particles and gamma rays. Since those discoveries, we've learned a lot about radioactivity, the dangers as well as the benefits. Radioactivity has given us medical imaging, a treatment for tumors, a method for calculating the age of the Earth, and a power source for our spacecraft to explore the solar system. Even some smoke detectors contain a small amount of radioactive material called americium, which helps create a steady electrical current. When smoke particles disrupt that current, it triggers the alarm. Centuries ago, alchemists set their sights high. They sought infinite wealth and immortality through miraculous transformations of matter. They came up with useful tools and glassware, but not much else. Chemists, on the other hand, set their sights a bit lower and ended up changing the look and feel of the material world, as did our next great discovery. In the 1860s, John Hyatt, a printer and amateur chemist in Albany, New York, made news when he discovered a way to exploit the long, stringy molecules of cellulose found naturally in plants and created the first plastic. 50 years later, Belgium-born chemist Leo Baekeland took the next step in the discovery process.
One of the great pioneers was Leo Baekeland, who made a polymer called bakelite. The usual thing, chance favoring the prepared mind. He was mixing things, but he knew how to explore them. He saw the interesting properties of this.
From two chemicals derived from coal, Baekeland discovered the world's first fully synthetic plastic. And the landscape of the 20th century was forever changed. What exactly is a plastic?
Plastics are polymers. So what are polymers? Polymers are long chain molecules, not individual molecules that are then clumped up into a solid of some sort. They're really molecules that extend out very far. Chains of carbon atoms, sometimes with some other elements in them. So what are the advantages? Well, it's moldable. You can pour it in some liquid form into some mold. Strength, well, it's not bad. You can make bulletproof vests from plastics. And we've certainly seen that in terms of fibers, they can mimic or even surpass the properties of natural fibers. No fisherman in the world is going to go back to having nets out of cotton, you can bet. Those nets are going to be out of nylon.
So would you say the discovery of plastics is a great discovery?
We have science making polymers, making nylon, making rayon, which has a natural starting point but is modified into a polymer, making plexiglass or polyethylene. Those are the structural materials of our civilization. I think polymers are, in that sense, an example of the human creativity of chemistry. There's just nothing more beautiful than them.